Sweet. Thanks for coming today. My name's Darron Froese. I'm Darron on Twitter and Darron on GitHub. And when I'm not crawling around an underwater wreck, I'm a site reliability engineer for Datadog. To start things off today, let's briefly talk about what service discovery actually is. So in its simplest form, and for our purposes today, it's comprised of two main components. Service registration, where some service on some node or in a container or maybe even in a unikernel says to a central authority, I provide this service to, at this IP address and port. And on the other side, from there, service discovery is the other component. So where some process on a node or in a container says to that central authority, hey, can you tell me where to connect to this service? Now there's obviously other parts around that, but that's what we're going to focus on today. That's really it. So Datadog's journey to service discovery started near the end of 2014. We had about 370 VMs in AWS. We were ingesting about 1.2 million metrics per second. We've been around for 4 years, but we were in the process of cutting apart our monolith and taking out the components piece by piece. So we were growing in staff and in machines we monitored, and we were having some pain around configuration management. So rapid growth is always challenging. It exposes, the areas you need to deal with next. We had gotten to where we were by doing things a certain way, but we couldn't do those things the same way anymore. In order to scale to the amount of traffic that we were seeing, we needed to add many more machines to share the load across our entire platform. As that quote indicates, you can get pretty far. In our case, up to 400 machines. But it was increasingly getting cumbersome to manage raw IP addresses. We needed a better way. And by the way, you might not be able to see it, but there's an article at that link at the bottom at the blog, and it's great. Even though it's 2 years old, it's got lots of good stuff in it. So at the time, we were using a hybrid of chef searches that take about 30 minutes to update, and large numbers of manually managed IP addresses. Those environment files in our chef repository, those are some of the hottest files that we dealt with on a day-to-day basis. And there's nothing really wrong with that, but it was getting harder and harder to manage. As you can see from the graphic above that I unfortunately had to obfuscate a little bit, the amount of services that we were extracting out of our monolith and adding to our application to keep up with growth was growing and growing. If we were to prepare for the future when we all move to containers, pods, and unikernels, there's no possible way to keep all the locations of all the things in a single static file. Plus, it's really error-prone to manage that file. It was getting really troublesome to merge. We could see the writing on the wall. So I had first used Consul back in 2014 of June for to serve as a backing store for environment variables from my Docker project Octohost. I was only using the integrated key value store at the time, but I knew that it included service discovery, and so I wanted to give it a shot. So I got approval to take a quick spike into seeing if it would work for Datadog, and here I am 16 months later, still on that quick spike. At the time, we thought our desired end goals were pretty simple. We wanted to have register and provide a catalog of services on our cluster, and provide an integrated key value store in our cluster. And unfortunately for people who like to complete things and move on to the next project, those two little goals led us to an almost infinite amount of yak shaving and rabbit trails that on the quest for infrastructure nirvana. So some of you may not even know what Consul is today, and thanks for coming regardless, but I'll go for a quick introduction. Consul is a great tool written by the guys at HashiCorp. And there's a distributed and strongly consistent key value store that sits in Consul that you have access to from any node in your cluster. It has pretty flexible ACLs that allow you to lock down parts as needed. You can register a watch against the keys in the key value store, and when the key changes, it'll automatically run a handler for you. Very, very, very efficient way to get information out. It has an opinionated service discovery framework that gives you built-in DNS and HTTP endpoints to query. You can also create locks, you can do remote orchestration and job execution as well. It's really quite cool. Consul has server nodes. Yeah, it worked. Nice. Consul has server and agent nodes. You run Consul on every node. So the binary is identical. The only thing that changes is the configuration. So the server nodes participate in the Raft consensus protocol to keep things consistent. It's how they agree in a distributed system. There's always a single leader out of those server nodes, and if the leader slows down and stops responding, the other server nodes have an election, kick out the guy and start a new one. That leadership election is not really a big deal. It's not like a Postgres failover where you actually have to do something. It's hands-off and it happens automatically. Now, during that election, for approximately 5 to 10 seconds, it depends on your network, you can't read or write to the key value store in most of Consul. It's kind of in a degraded state. If you have time and want to learn more about Raft, that animation can be found and lots of information at the link above. It's got some great explanations of what Raft actually does. So given that Consul is awesome, and it is, I'm telling you, we still weren't sure if it would work for us and if it would help. How would it fit into our environment? How would it work given our needs? How would we even end up using it? We really had no idea. So we rolled it out into staging. There were about 100 nodes in that environment, and we used M3 medium size for the server nodes. Our phase 1 plan was pretty limited. It was really just an initial deploy of the server and agent nodes. We added some registered services, and we were exploring the service catalog. We really wanted to see how would it act in our environment, and would it interfere with anything? We quickly found that no, it didn't interfere with anything. In fact, the agent binary only took between 15 and 60 megabytes of RAM on each node. Everything seemed pretty calm, maybe a little too calm. Now, given that I work for Datadog, and Datadog monitors things like Consul, this is the part of the talk where I say, you need to be able to monitor Consul if you want to roll it out. At Datadog, we have a philosophy of monitor first, which means if we can't monitor it, it most of the time doesn't get rolled out into prod. And it really helped us with rolling this out. Over the next couple weeks, we built a Datadog integration to monitor Consul. We learned how to break it. We learned how to fix it. We figured out that it likely wouldn't break the world if we wrote it out to prod. So it's probably fine, and we shipped it. We shipped it in the state that it was, enabled and not really being used. So sort of like a dark launch. It was running and active on every node, but we didn't depend on it, and it wasn't being utilized except in a very exploratory sense. At that time, we were about 370 nodes in production. We spun up 5 M3 large instances, and then we started adding agents. 3 at the time, you can have 3, 5, or 7 server nodes, and at the time, 3 didn't seem to be cutting it. It was having a few too many of those leadership transitions. So we wanted to have a bit more cushion to survive a failure if something was to happen. And to the astute viewer, no, that's not a token ring, that they're not being connected in a circle. They actually all connect to each other. Every node actually talks to every other node. When everything finally got rolled out into prod, it was stable, which was pretty awesome. During our first explorations in staging, we had discovered what we considered to be the 2 most important metrics to monitor to know if Consul is working correctly. Do I have a leader? And when were the last leadership transitions? Was there one recently? Overall, these metrics will tell you whether or not your cluster is healthy. If you have a leader, well, then things are good right now. And if you've been having lots and lots of leadership transitions, even though they're hands-off, that's not really a great sign. We're going to come back to this because those 2 metrics play an important role in today's talk. So now that we're live and on prod, what do we do? One of the first things we did is we added what's called a Datadog service. We wanted to use the Consul service catalog to have every node in the service catalog so that we would be able to do all sorts of fun stuff with it. Fun stuff like the next slide after this, of course. So we use Chef to install the service as a small JSON file. That's an example of what the JSON file ends up looking like. We also use Chef to add all the nodes' roles and the availability zone as tags. So now that we had a complete picture of all nodes, we could do things like Can you guys see that? Oh yeah, sweet, okay. So we could use a command that we called SSH to role, where we could SSH to a node that had a specific role. We could also use another command called host by role to find all hosts with that particular role. It's incredibly useful, and it's the primary way that people get around our clusters today. At Datadog, we already had an orchestration solution that many of you are probably familiar with called Capistrano. It did all sorts of things for us, and Consul has something that's similar called Consul exec. Now, it can run any command you want on any group of nodes. We're limiting that command to just the Consul server nodes. The catalog of nodes is always up to date as nodes are added and removed to your cluster, so you don't have to manually do anything, which is great. And it's fast. It's pretty nice. So things that used to take multiple minutes under Capistrano, you can do in 5, maybe 10 seconds if everything's slow. Unfortunately, we aren't super happy with some of the security trade-offs with Consul exec. You can't really turn it off unless you really do a lot of extra limiting that we weren't willing to do. So most of the time it's disabled, except when I need to do something really fast. Sorry, Mike, wherever you are. One quick pro tip, if you're using Consul exec, do not tail a large or active log file, because all of the server nodes participate in sending you those bits and all have to agree. They use RAF to agree, and that's a very quick way to melt down your server nodes. So they're aware of it. I'm hoping there's maybe a fix, but we'll see. Remember the strongly consistent key value store I talked about earlier? Well, turns out it's really handy to have a global data store on all of your nodes that's available from localhost and an HTTP call away. So we wanted to use this for configuration data, but we also wanted to know who made a particular change, and we wanted to know when those changes were made. Turns out somebody already built most of this, and Git to Consul is the solution that we used, and it works great. So we took Git to Consul, and we created our config repo that has some selected configuration data that's widely used across our stack. It's a very popular repo at Datadog. Who knew that if you build something that's really easy to use and does things quickly, that people use it a lot? Every 60 seconds, Git to Consul checks to see if there's any changes in the Git repository, pulls and merges those changes into the key value store, then Consul distributes those changes to all nodes, and the processes we have in place then act on those changes. So it's given us a whole bunch of really cool capabilities like quick reaction time and flexible configuration. It's also capable of sending a broken config file to every node very quickly. It's a tool with a very sharp edge. So as we were using Git to Consul and our Consul config system more and more, and because of how we were using and abusing Consul, this exposed what we felt was the weakest part of Consul at the time. And that was how Consul reacted when we were reading from the key value store at a high velocity. So Consul's leadership transition mechanism is tied to latency. After not hearing from the leader for about 500 milliseconds, for whatever reason, the other server nodes kick it out and elect a new leader from that group. The old leader kind of comes back with its tail between its legs, promises to do better next time, and joins with the others waiting for its next turn. When you read from the KV store at too high a velocity, or from too many locations at once, Consul 0.5 has a tendency to freak out and have those leadership transitions. As you can see, the above graph from January to May, it wasn't that awesome. And in all fairness to HashiCorp, this was at least partially self-inflicted. Each leadership transition took approximately 6 to 10 seconds on our network to be complete, and during that time, again, the KV store is unavailable for reads and writes. So we adjusted our code, we made it a little more tolerant of those interruptions, and moved along. Here we are at the end of May, and everything's trending up and to the right. We're growing in all areas as we start to use more and more features of Consul. By this time, we're getting serious with service registration. As you can see, we only go up to the letter D there. Many of our services were being registered, and we're playing with how to use the various discovery mechanisms. There's a simple HTTP API that's built into Consul that can answer many things about nodes and services in your cluster. It's flexible and easy to use, but for us to use it would require a little bit too much re-architecting of some of that monolith. So we decided not to go this route in our app and in our extracted microservices. We decided to primarily go with the DNS interface, at least for us inside of our application and those microservices. So it's simple and flexible. As long as you know the name of the service, you can easily get a list of IP addresses where those services are running on. As with anything to do with DNS, it has its own drawbacks. There's some strangeness with some libraries, but it just works the vast majority of the time. Our newest services, a custom data store and a metric service that we deployed last summer and fall, the only way to get to them is through this DNS interface. There's no other interface allowed. As we add additional instances to handle the load and handle our requirements, those new nodes are added into rotation in the DNS updates, and we're good. As with anything new, though, we were worried about services being unstable, flapping in and out of the service catalog. What would that do to our app? Would it happen because of Consul? Would the health check mechanism work as we hoped it would? So we did what many pragmatic engineers do, and we cheated and rigged the game a little bit. In some case, like the above, we made it never fail by calling bin true every 60 seconds. So it's never going to fail. In other cases, we remove the check altogether. In still other cases like Cassandra and Kafka, we use proper health checks at a decent interval. And I'm happy to say that service flapping generally isn't a problem. I know some of the HashiCorp team have told us that there are some issues with services, but it's not a Consul's problem. We're at least not seeing it. And we have many, many services. If your service is flapping, in our experience, it's because your service is flapping. Right? Sometimes we'll see a bunch of Cassandra nodes roll in and out of the catalog, and that's because it's Cassandra doing whatever the heck Cassandra's doing. Right? It's proven to be a very reliable mechanism. Another quick pro tip on the whole flapping thing, Consul has the concept of a data center. Within that data center, every node needs to be able to talk to every other node on multiple ports on TCP and UDP. So if any of those aren't correct, or you have some firewalls and things like that, that's when you see flapping. But again, that's not a Consul problem. One of the side effects of having a very fast-paced system that ingests millions of data points per second is that using DNS was always a very risky endeavor. Like, everything's always a DNS problem, right? In fact, before Consul, we didn't use DNS internally at all. It was always bare IP addresses for the speed. And given Consul's proclivity for read-induced leadership transition, we were a little concerned about what adding millions of queries per second to hundreds of machines would do. So we did a few things to help mitigate this. First of all, we installed DNS mask in front of Consul, so we wouldn't be querying Consul directly. DNS mask will intercept anything with a .consul domain name and direct it to port 8600, which is the port that Consul listens to for DNS requests. Secondly, we added a short 10-second TTL to all of the services that Consul knew about. Consul's TTL by default is 0, and that's just a little too quick for us. So we also looked at creating a host file based on the contents of Consul's service discovery database. Okay, I guess that's the end of that slide. So we looked into our existing bag of tricks around Consul. We grabbed Consul template, another HashiCorp product, and we started with that. Our plan was to build a host file on every node and load it into DNS mask directly. And it seemed like the most straightforward option, and it would have been great. But even in our staging environment, it was chaos. It looked a little something like this, but with everything flying and no little girl. When everything was updating, when each node was querying Consul service catalog, it was putting so much repressure on Consul's data store that it was pretty much eternal leadership transitions. Multiplied those nodes by the number of services and the number of records for each service, and yeah, it was not feasible. To be clear, again, this is not Consul template's fault either. And a nice side note is that Consul 0.6 fixes this. But here we were, Consul 0.6 was still a twinkle in HashiCorp's eye, and we couldn't wait until December. So we got to thinking, let's build this host file on one node. We'll use the KV store to distribute this file to all the nodes. We'll use one of those little nifty watch things to write it out to the node on the end. And it worked. It worked really, really well, actually. We weren't seeing any problems at all. There was no transitions. There was nothing. It was super stable. We very quickly found out that without rate limiting that process, reloading all of your Consul agents for whatever reason on each node leads to those services dropping in and out of the catalog. And if you're dealing with an automatically generated host file that has all the nodes in it, say over a 30-minute chef run, that's about 20 nodes per minute that were dropping in and out of the catalog, which meant that 40 times a minute, this host file was being regenerated, sent to 600 nodes at the time, and written out. Every 1.5 seconds it was doing that. And that was pretty stressful for me, personally, as I'm watching it. But we made sure to enable some rate limiting, and there was one thing that we noticed during this entire process, one thing that surprised me, is that there wasn't a single leadership transition during this entire time. That even then we were sending around this 40K file to 600 nodes every 1.5 seconds, there wasn't a single problem. Consul didn't crack under the pressure. Whereas on the other hand, with our Consul config repo, every single time we made a config change and Consul updated, we had between 1 or 2 leadership transitions. It wasn't a big deal, but it happened every single time. So this was an important clue for us to learn about how to handle Consul. The very next day, this anonymized commit, obviously to protect the blameless, sailed into our configuration repo and says, JSON files are now pretty and standardized. So somebody took it upon themselves to lint and clean up some inconsistencies, and that's great most of the time. It's normally a really good thing, but that's not. This was the next couple of hours while we valiantly battled against Consul and Git to Consul. Git to Consul would grab the changes, it would try to load them into Consul, the first few keys would get updated, the watches would fire, everyone would try to grab it at once, crash Consul, then Git to Consul would crash. So it was tons of fun. It was way too much read pressure, and again, we were seeing that limitation. So in the end, we ended up having to disable Consul on a whole bunch of different nodes, and then allow Chef to restart them over the next 30 minutes slowly. So what have we learned here? Well, one of the first things we learn is that it's very hard to be one of the early adopters of a new distributed system. There's no Consul Stack Overflow where you can go and just steal some magic incantation that will fix everything. At the time, there was really very little real-world information available, other than the docs, which are great, but we wanted to know how other people were using and deploying this. Another thing we figured out at around the same time, and something that I suspected for a little while, is that we were sort of doing it wrong. Blamelessly, of course. We had about 100 tiny keys, and these tiny keys were the keys that were being read at an extremely high velocity across the whole cluster. Essentially, we were DDoSing ourselves. And this was not the sort of problem that showed up in staging, of course. That staging didn't have enough nodes. So we didn't know that this was the problem until it was a little bit too late. But just to remind you of the facts, so Consul servers throw a coup d'etat when the leader just can't keep up. It can't keep up because it's doing all of the things all at once. Bigger CPUs can do all of the things and more of the things at once. And we're in the cloud at Amazon, and what the hell, we just raised a Series C, so we went to bigger nodes. We upsized our server nodes. We deployed these new and bigger servers one by one, and we put the old ones kind of out of their misery. And it was good. And things were beginning to be made right again. They were still happening, but nowhere near as much. We just took a little detour and talked about leadership transitions. And you might be asking, well, how did the DNS mask and the host file go, Darren? Like, what happened with that part of the story? Well, to let you know, because I know you're all really interested, it worked really well. You might be able to see the above. We added, or the below, I guess. We added an additional host file and then gave it a 10-second TTL. And DNS mask is one of the few things in the known universe that actually seems to honor a DNS TTL properly. It works great with Consul. In testing, you can see it only forwarding the first request, serving the cached answer for the next 10 seconds, and then going back to Consul to re-resolve. It's pretty nice to see software that actually respects a TTL. And it's quick. Like, I'm not a DNS guy, but I was trying to measure with DIG, and I was getting 0 milliseconds, which is obviously pretty hard to measure. It's 0. So I built something to query for me, and for items DNS mask sends to Consul, on this node, it takes between 600 and 700 microseconds to get an answer back. When DNS mask is serving out the cached answer, it's between 100 and 200 microseconds. And for things that DNS mask has in a host file, it's, again, between 100 and 200 microseconds. So fast enough for us at the moment. I added some metrics generation around a DNS mask log watcher on one of our nodes last week. And this single machine, one of our 1,000-ish, is constantly doing about 20,000 Consul DNS requests per minute. So clearly the Python libraries are not respecting the DNS TTL, but it's querying DNS mask, and I don't really care. So because of the multiple responses, there's about 50 to 60,000 responses per minute. Querying Consul directly on our system would be mayhem. It would be a problem, like, to put it mildly. So take this and multiply that by 1,000, and yeah, it just wouldn't work. So even though we've been having some success with Consul, we were still sort of tiptoeing around. People were freaked out. We were only at 600 nodes at the time. What would happen as we grew even further? We had already doubled in size from previously. Internally, there were some concerns as we scaled. Like, they didn't trust that Consul would be able to keep up. So a parallel service discovery app was written and deployed beside Consul. Unfortunately, it's still there. I'll get to that at the end. But some people were certain that the apocalypse was coming. And I honestly wasn't sure either. The next month, so this was in August, we hit 700 nodes. And it seemed that the fear was warranted, as all of a sudden nodes started randomly going deaf and mute. They couldn't talk to the servers. They couldn't see the updates that we had placed in the key value store. They lost their Consul locks, so the services disappeared. You know, those 2 services where Consul is the only way to find them? Yeah, that was not good. Oh, it was bad. So when we bounced Consul on those nodes, it usually fixed the problem, but like, that gets pretty tiring after 5 minutes. And the biggest problem was that I couldn't duplicate it reliably, but I could see the grumbling in Slack whenever it happened. Shortly after that started happening, I was in New York for the week. I worked from Canada most of the time. And I heard someone mentioning, I heard someone mentioning it, that it was deaf again. So I immediately went into Brendan Gregg mode, well, at least partial pseudo Brendan Gregg mode. And I was finally able to duplicate it reliably. And then it cleared up. So I did what we normally do with Datadog, and I made some graphs. I wrote some code to watch the URLs that were exposing the problem, and I waited. These graphs and a large amount of Wiresharking that James from HashiCorp, who's sitting right over there, ended up reading a lot of, thank you, sir, helped us to track down what was happening. A server node, or nodes, was losing their connection to the leader. And as a result, the agents that were talking to that particular server were going deaf as well. HashiCorp quickly found and fixed two deadlocks in the multiplexer code that was underneath it. And there was also another bug that spun up hundreds of additional connections per node that was proving to be a bit of a problem. But it was still happening. The last puzzle piece dropped into place when James, again, I owe that guy many beers, asked me about the Zen AWS Linux bug, the rides the rocket bug, the old Quake reference, which we thought we had fixed, but for whatever reason it was still there. It was still happening, and it was interfering with the server and agent communication. They were dropping packets that, just never got read. So a couple days later, that bug was totally eradicated from our systems and prevented from returning through judicious use of Chef Fu. So I held my breath, and I just kept the GitHub issues that our team had filed internally. They remained open, and the parallel service discovery app ran alongside Consul. But the tide had turned, and the sentiment was trending in the right direction. That takes us up to October, and we're fluctuating between 800 and 900 nodes at this time as we're retiring some services and adding some new ones. Kafka is one of the most important systems at Datadog. All the data that we ingest goes into Kafka, and all of the consumers read from Kafka to do all the things with all the metrics. So in October, we used Consul config to completely swap out our primary Kafka cluster without so much as an external peep that entire time. It was pretty cool. We also started using Consul exec. And so Consul events. Consul events are sort of like Consul exec, but with predefined actions. So you can't just do whatever you want. You do the things that it tells you that you've already predetermined. So that watch right there, what it does is it waits for an apt update event, determines if this apt update event is new, and if it is new, it's not an old one, then it actually runs apt get update. In our old cluster, using Capistrano, it used to take between 20 and 30 minutes to do an apt get update. And that was if the static file was exactly the same when you started the update as when you were getting to that node that was in there that might have been removed. If that was the case, then it would crap out and you'd have to do it all again. Now, it takes between 60 seconds and 90 seconds to run an entire apt-get update in over 1,000 nodes in production. Our staging environment takes about 10 seconds now. We were also using Consul lock for a number of processes. And I got to take a drink, sorry. With Consul lock, you can run a highly available application and have a hot spare step in if something happens to the currently running application. So we normally run 3 instances of these jobs, and with only a single one running, when that one would decide to take a rest or crash or do whatever it feels like doing, then one of the remaining processes will automatically take over to make sure that there's always at least one of them running. It works pretty well, and we have a few of these at the moment. Git to Consul runs under this, so it's always pulling in the Consul changes. And our DNS host file runs under this as well. Here's an example of an Ubuntu upstart script, there we go, that works with Consul lock. It's pretty easy to get quite a bit more reliability out of an unreliable application that you know is going to crash all the time. When the leadership transitions grew, we again bumped up the size of the server nodes one more time because that's what you do with Consul 0.5 when you get a lot of leadership transitions. Now, which is the very bottom right, obviously, we see a leadership transition every 1 or 2 days, and that's it. It's pretty awesome. And this is one time where money did buy happiness, at least my happiness. So one important note is that we had 2 small outages last year related to Consul, but at no time during this entire period was it ever Consul's fault. Or was there ever something that happened to Consul that we couldn't explain? The first time in March, we had a 3-minute outage that was caused by a packaging chef problem. And that was kind of annoying, but it was quick and it was done. We had one outage in July that was related to somebody who, again, shall be blamelessly nameless, they restarted all the server processes at the same time. And that is, unfortunately, one of the big no-nos with Consul. You don't do that. Just don't. That's a pro tip. Just, hey. So Consul's been super solid this entire time. In fact, there's been more than one time where some kind of network partition has happened in US East. It's Amazon. You never know what's happening. It's always still green, of course. But there have been more than one time where this has happened where either Kafka or Zookeeper or Cassandra or something has got screwed up and we'd have to intervene. We've never had to intervene with Consul. We just break it ourselves. As a side note, if you want to come work on these sorts of fun problems, we're hiring. So make sure you come chat with me or go to the website. Just let me know. So here we are at scale. It's January 2016. And what can I say that we've learned over the last year working with Consul? Well, no matter what you heard me say during this presentation, Consul is awesome. It acts like an incredible data center backbone that helps to scale your operations by having these helpful primitives available to you alongside orchestration tools, persistent local data store, service discovery. I'm a total fanboy, and if you can't tell already, I love it. And I promise you, I don't get a cut or a kickback from HashiCorp if you run it, but you all should if you have a need like this. Even the Hoff loves it. Like, what's not to love? So monitoring as you deploy it is not optional. It really should be a no-brainer. I happen to know a few people that might be able to help with that, but just, again, just saying. If you're starting out, make sure you upgrade to 0.6. And if you're not there yet, find a way to upgrade. It's really not that hard. I did it a couple weeks ago in an afternoon. The HashiCorp team took a lot of community feedback and a lot of the bugs that I've been filing for the last couple of years, and they ended up totally rewriting the storage backend. Version 0.6 has completely solved our read velocity issues. It's not to say it doesn't occasionally leadership transition, but it's not every time. In fact, like I said, it's once every couple days now. They also fixed a number of bugs and added a whole bunch of new features, ones that I haven't even touched today. The new client binary takes about 1/3 of the memory from before, so from the 15 to 60 is now quite a bit lower. It's now stabilized down about 20. The servers take up about 1/4 of the memory, and it's a little bit harder to see, but that red line is when I finished upgrading all the Consul, all the server nodes. And now it sits around about 1/2 gig. It moves up and down a little bit, but it's nowhere near 4 or 5 gigs that it was before. When's the last time that a software upgrade actually used less memory, right? Consul 0.6 is the bomb. There's no question. So Consul servers really love a sizable CPU. So make sure you feed it the right size of machine. If you're in the cloud, just make sure to upgrade your server nodes until you don't see leadership transitions anymore. If you're not in the cloud, then get your PO in early and get yourself some new machines racked, because it'll be a while, but I have some example sizing that I did with 0.5 specs. So you might actually be able to get away with smaller nodes now because Consul 0.6 is just that much more efficient. And as always, your mileage may vary depending on how you use it, how many services, all those things. One thing that's been emphasized through this whole process at Datadog has been to architect for failure better. Consul is a distributed system, and so you don't have the luxury of having everything on one node. Connection problems will happen. Nodes will connect and disconnect. Add retries to your connection routines, add exponential backoff and circuit breakers. All these things will make your stack more resilient. And that's obviously not a Consul-specific recommendation, but something that was really pounded into us when we were dealing with last year's shenanigans. So the next one's fairly self-explanatory, and it's if you're inducing consistent leadership transitions with the velocity or volume of your reads, you need to upsize your server nodes or change how you're doing it. For example, if you're running an app server and the app server spins up multiple processes, please don't make each of those processes read from the KV store on the same node. That's bad. If you can avoid having each process do that, it's a pretty big win. Make efficient use of these connections, and Consul will go much further. If you've got a number of machines reading all of your keys at once, then you might end up having a lot of pain like we did. One thing we're looking at trying now is using fewer and larger keys. Not anywhere near the 512 kilobyte maximum, but having lots and lots of really small keys was really the root of a lot of our problems. One thing we decided early on was to lock down the key value store using those ACLs, so that changes were only coming from places that we knew and feeds that we could audit and examine. If your configuration can induce behavior change, and configuration's supposed to be able to do that, then having it available as a free-for-all is a bit of a nightmare. Lock it down and make those configuration changes auditable. Consul watches are super powerful, and it's how we distribute the data using the key value store. But they can fire a bit too often. So I have a small Go utility that I built on a weekend that we've been using to make sure that it only fires when it's a new event. So it tracks the state at the time of the watch last fired, and then if it's the same event, it doesn't fire again. So it's called Sifter, and it's available on GitHub. So we use it in production at Datadog. It's pretty nice. My last tip is pretty key. If your output isn't unique and you can get away with it, then don't build your configuration from Consul data or services on every node. Build it on a single node, and then use the KV store as that transport mechanism. Now that's my last tip, but related to that last tip, I have one more thing today. The last year has been a huge learning curve for us working with Consul, and transporting configuration data using the KV store has been a very pleasant surprise. It's fast, it's stable, it's reliable, and so we've been steadily revising how we do it. As with many things, the first version was written in Bash, the second version was written in Ruby, and the last version is written in Go. We've been using it in production now for a couple of months. It operates tens of thousands of times per day for us, and it's been really fun to develop. It handles that delivery lifecycle, the inserting the configuration data into the key value store, as well as the extracting and delivering it on the other end. We also have a chef cookbook that helps you to create the Consul watch that's needed to most efficiently distribute the config files. So we call it KV Express, and we're making it available today. It's a tiny Go binary. Again, it handles the inserting and delivering of the files. It emits, we're a metrics company, and it emits metrics and events, just so you can audit and measure what's happening. The file that's uploaded is the same as the file that's delivered. We compare hashes to make sure that it makes the journey intact, and we only use the finest of all the hashes. So it's efficient. If it doesn't change and it's trying to be reinserted, it stops, it doesn't reinsert it. If Consul thinks that the watch needs to redeliver it, it checks to see if it's the same file and it doesn't redeliver it. It's optimized for safety because we don't want to write a blank file, and because that's generally pretty bad to whatever service depends on that config file. And you can also run commands after the file is delivered. It's also super fast. Once it triggers from a Consul watch, it's under 500 milliseconds to deliver a 40 kilobyte file to 1,000 nodes. The stats are weighted most heavily under about 300 milliseconds, but there's always the stragglers that make my histograms and heat maps look terrible. I originally tried to measure the entire process from start to finish based on syslog timing, but everything was happening within a single second, so that wasn't helpful. So I added some higher precision logging, and inserting to the key value store takes usually about 100 milliseconds and under, and that's on the left. And delivery from the key value store usually takes about under 300 milliseconds and down, very often much closer to 100. When it inserts records into the key value store, it can throw out an event to Datadog so that we can audit what's happening. You can see on the bottom we added some Postgres node somewhere, and on the top there's a Kafka node that's getting removed as well. These events can be shown on a timeline, they can be graphed, they can be measured, you name it. Again, because we're a metrics company, we emit a ton of metrics. The size of the file, the lines in the file, because we don't want, again, zero-line files are bad. When it's firing, how often it's firing, how long it takes. We also emit like other things like panic metrics, not long enough metrics, checksum mismatch, things like that. And I have a quick, very, very quick demo. Should take just a couple minutes. I originally tried to make a video of the demo from start to finish, and unfortunately, even for me, it was super boring, because it's kind of one of those things that happens in the background. So what I'm going to do today is I'm just going to show I'm going to clear that, and I'm going to show an ad hoc usage of KV Express on a prod cluster, so don't tell anyone. In addition to be able to using watches to deliver things, you can also, sometimes you might need to deliver a config file to a bunch of nodes quickly, right? Because you're having an outage, you need to change something, and Chef is busted or something. So we also have something we call ad hoc usage, where I set aside the temp key space in that program called Consul, the temp key space, and we can use that to write. So I'm just going to cat my demo script. And so here, I'm just going to sudo. So this command is the in command. It says KV Express in. I'm feeding it a URL, and it's just a 600-line config file I grabbed from a SaltStack website this morning. And I'm going to insert that key into the scale 14x key and in the temp prefix. And so when you do it with the URL, it automatically shows the output just to make sure that the thing that you put in is the right thing. And if we take a look here, kv ls grep temp, we can see it's there. So console kv get scale 14x checksum. So there's the SHA-256 checksum for that that text file that we grabbed. So what I'm going to do here is I'm going to take this file again. And so this is a Consul exec. Again, it's one of those scary things that sometimes you get to use. And what we're doing is saying for the service data dog, run kv express out, minus d is send out the metrics. For the, again, looking at the right key in the right prefix, and we want to write it to temp/scale 14x.conf. And then the -e at the end is this, they're running the command at the end of the process. So you might, if it's a config file for Apache, you might want to do sudo service Apache restart or something like that. In this case, I'm just going to, well, correct the file name first so that it's not remaining there. And I'm going to change the name because I think I did this a few times testing already today. So like I said before, if it's the same file and the exact same text, it won't do it. So that's going to go across 1,100 nodes, 1,200, almost 1,200 nodes, and it's done, right? So it's kind of fun. Before we used to do that with Capistrano, again, it would take, sometimes we would just end up stopping, like stop everything and do it slowly because it would take so long to do everything in parallel. So there. So that's KV Express. It's available there as soon as I can click open. So it'll be available quite shortly. And I think we have time, a little bit for some questions. So, sir.
Yes. Can you talk a little bit about encryption, KV encryption for secrets? And the second question is on horizontal scaling of the leaders.
Of the leaders, okay. So, encryption for secrets. We don't have any secrets in there at the moment because there's no good way to do it at the moment other than maybe using something like Vault. So hopefully that now that this has calmed down and the presentation is done, now I can start working on Vault to do that. Now it's another HashiCorp product. It ties in with Consul. It's probably a better way to do it. We looked at a few other ways. There's nothing really good. As far as the horizontal scalability of the servers, like I said earlier, you make them a little bit bigger until the leadership transitions go away. Now, I don't see a problem with Consul 06. You could probably get away with 3 nodes in production, and it depends on your use case. There are some people who have very little traffic, very little read traffic. We have a lot, and sometimes we were hitting the key value store 1,000 nodes, some of them with 10 proceeds at once. We're reading 100 keys. We're still doing that, and it's still not breaking anymore under Consul 06. So it's great. It's ready for production. Unless you have 10 or 20,000 nodes, I think at that point it starts to break down. Did that answer your question? Okay. Anyone else? Oh, in the back, sorry.
Did you do a cost analysis of what would have happened if you not taken Consul? Like what was your major saving? You've gone down the road of not taking this, and now you've taken this. The amount of time and investment that you put in this, the savings that you've had. How would you summarize it?
Well, we're not saving any money, that's for sure. Not with those the C32XLs. We're not saving anything. The biggest problem was around that service discovery, and it really was whenever we were trying to update any of the things in that environment file, it was taking 2 hours to get out, and that's too long. If we had a problem, first thing people would do was, okay, stop chef, everybody, right? And we would stop chef, and then we would roll things out manually just because we didn't have enough time, and no one trusted chef. Chef's great, and we use a lot of it, but just in that 500 milliseconds versus 30 minutes or 2 hours, you had a lot more capabilities that you could do. Like I mentioned earlier, when we replaced our entire Kafka cluster, we wouldn't have been able to do that with Chef without a lot of pain. And it would have taken us a lot longer than I think it was the 2 or 3 days that it took us. So it just gives us the agility that we need to do things, especially when things are hitting the fan. That's, sorry, so you there.
Can you compare KV Express to Consul templates deduplicate feature?
I know, that's crazy. We wrote it at the same time. Now, Consul template is great. We still actually use it to template stuff from the service discovery. The dedupe feature, and then now Armand had a talk on Tuesday, and Armand's one of the original authors of Consul. It essentially does a similar thing. The only thing that is different, now we've integrated into our chef workflow so that we use an LWRP that when it goes through chef, it looks to see if there's a file there. If there's no file, it grabs it through KV Express, and then it writes the watch automatically. So we don't have to do any of the setup on every node for all of these watches because it's handled through the LWRP. Essentially, they're both doing very, very similar things, and if that had been available in November when I was writing this, then we might not have done this, but it wasn't, so. Sorry, sir.
Are you guys using, did you ever look at using the stale consistency mode?
Oh, yeah. We do all that. We have stale, we have all that stuff. We actually never found some of the consistency modes to make it a very big difference in our environment. I might have been doing it wrong. I know I do a lot of things wrong, but we never found that to be a very big difference for us.
So you switched it off?
We still have it on, but it really doesn't make a difference.
Currently doing stale consistency mode.
Yes, we have some of the KV requests that we make are in that mode, yes.
And that's like 50 milliseconds?
You know what, I'd never got around to timing it at that time. It was more just get it to work because everything's burning. So, yeah. Sorry, over here?
So you mentioned Zookeeper and Kafka. So it seems like Consul is sort of like, did you find that like it was easier to work with than Zookeeper? And the second question, Kafka. I know there's a AWS service, these are on AWS, so there's also Kinesis. And is that like, it seems like these are both maybe newer evolutions of the same thing?
Sure, so your first question, so Consul comes with all the stuff with Zookeeper. Consul comes with all the service discovery built in. So that parallel service discovery app that we wrote was based on Zookeeper because we have a bunch of clusters because of Kafka. But it doesn't have the DNS interface. It doesn't have the services. Like, it's not built. You have to kind of handcraft it all yourself. And we like Zookeeper. It's pretty good. But for this, we also wanted to be able to use HTTP to query it and not have to have a really thick client, and that just isn't available for Zookeeper as far as I'm aware. The second question was around?
Kafka.
Ah.
Are you still using Kafka and not Kinesis because legacy or
Well, part of that is we don't get to depend on any stuff that only AWS offers. And we're doing about 5 million metrics per second. We've increased 5 times over the last year. A lot of the things that Amazon comes out with right away, they can't handle the volume that we're at the moment. So at this point, it would be nice, I think, for some low volume stuff. I'm looking at using some Lambda stuff to throw it into Kinesis for things like logging and some metrics that aren't kind of our critical path. But Kafka is our if Kafka doesn't work, we're screwed. So that's just kind of how it is.
I'm CTO of Delicious. We got rid of Kafka in favor of Kinesis and just good experience.
Sure.
Dramatically simplified.
Sure, and it totally depends on your volume too. Like if you have a similar volume, then it might work. But again, for us, we couldn't at the time. Anyone else? Bueller? Sorry, I saw you first. Sorry. Yeah, you.
The 300 millisecond propagation time that you mentioned, are you guys just on the East Coast, or are you doing like multi-data center?
No, sorry. That's 300 milliseconds from the time that the watch fires in the console on the local node to the time that it's done writing the file and finished. So it's all in one data center, but that's, so I actually wanted to measure for this talk, I wanted to measure, so how long does it take to write, and then what's the gap in between the two before they start reading? Only problem was with NTP, I couldn't get the sub-microsecond precision, so it was before it was even done writing sometimes, nodes were already starting. So I want to figure that out, exactly how long it takes, but it's so fast as to be, I couldn't measure it yet.
So you are doing like multi-data center replication?
No, we're still in, we're in 3 AZs in US East at the moment. We have hundreds and hundreds of terabytes of data in S3 and in all sorts of other things, so it's moving to multi-data center is pretty interesting for us. So, sorry, you.
Hi, you mentioned earlier using, like, switching to all DNS, using DNS maps to load a file that you build and then spread around. And I believe that was to reduce the load of reads on the whole system.
Yes.
We are using Singularity and Mesos services, and so our services are on consistent ports.
Yeah, that'd be a problem for this, for sure.
Do you have any of that kind of situation, or you just don't have that?
We don't have that. We don't have that situation. We're still all on VMs, and we have consistent ports. Containers haven't been an option because of the amount of data that we have. We have almost nothing that's stateless, so we can't use containers at the moment. And when we go down that route, we might have to go an overlay network or something. Maybe you would do like lib network or something else that has like IP addresses per container. But otherwise, you'd have to use SRV records, which Consul supports as well. We just haven't needed to yet.
Well, I guess you could still use the DNS master that does.
Yeah, I think so. We haven't tried that yet. So, fair enough. There's another one, sir, over there.
Yeah, one was, how are you registering to the service discovery? And then I apologize if I missed something you said. I was also curious, you guys are using the service discovery with the SRV records or applications aware of console service discovery?
Yeah, our applications are not currently aware of SRV. They're not querying for that. We are registering with a small JSON file in each node based on the role from Chef. So when we have a Chef role, it writes a specific JSON file for that role only, and the JSON file registers the service. Again, once the node gets killed, the service goes away. Does that answer? Okay. Anyone else? Yes. Oh, one back there. And then, sorry, you after that.
Are you using any of the new features in 0.6, like for network proximity?
Not yet. Just like I said, I just finished upgrading 2 weeks ago, and we haven't, but we're looking to that because of the AZs and some of the weird stuff we've seen between them. So we're going to try it, but we haven't yet. Sorry.
I didn't like your previous question, so apologies if you answered, but
No worries.
do you know if it would be difficult to roll out servers within containers in Consul?
No, so on my Octahost project, which is basically a very tiny, not terrible, but like a very lightweight Heroku that does none of the things that Heroku does around state. I register with an API call and point to those containers, so you can do it that way as well. We just chose to do it with these JSON files because the stability of our nodes and Chef. But you can do it with API calls, and it's no problem to, you say here's the port, here's the IP, and you're good. Did that answer your question?
Yeah, for the servers?
Yeah, you could. I know I do that. I host probably 60 containers on one box, and all of the config is built out of Consul service discovery catalog that's registered via an API call. So, oh, sorry.
Do you use like a console with Docker containers, like you discover like we take it to the Docker containers?
Sorry, I didn't totally understand that.
Console with the Docker containers, like did you integrate with any of them?
We haven't integrated with it, but I know there is some movement around that. I know HashiCorp is building their own Docker image, and I know there is some integration. I just haven't used much of it yet. Sorry. Okay, thanks for having me, everybody, and if you have any questions, let me know. Hey, man.